The following content has been provided by RWTH, Aachen University.
Will be about ARKit, so how to visualize information in the camera scene, camera view of your phone, to embed that with digital information. So to start off with, what is ARKit, or what is AR in general? AR is usually described with using the reality-virtuality continuum, and that is displaying the transition from the real environment until a completely virtual environment. So at the moment, we're in the real environment. Everything around us is real, physical shapes. You get feedback if you touch a table and stuff like that. And on the other side is the completely virtual environment where nothing is real. Everything is just rendered, and you can see it either on a headset, or also if you have it on your screen, that you see the virtual environment around and you walk through that there. And the space in between, there are a lot of different steps, stages, and where real environment and virtual environment are mixed. And that is what's generally referred to as the mixed reality. And two of the most prominent points, or most often referred to points, is on the one hand augmented reality, so where you have your real environment around you and there are digital information, digital models embedded in that real environment. So no one would expect a T-Rex to stand on a basketball court, but with AR you can embed that model in there. And moving down further the continuum, there's augmented virtuality, where mostly the environment is virtual, but there are still then links back to the physical world. So for example, that table at that location might be a real table, so you can go there and touch it, but it is displayed completely in a different way. And also the person can be displayed like such a avatar, or the real image of the person. So, and those are parts, transitions that are between the real environment and the virtual environment. And the most important takeaway from this is that augmented reality is not virtual reality. And that often gets a little bit mixed up. And as a help to decide whether it's augmented virtuality or augmented reality, in the further you go to the right, the more of your surrounding environment is virtual and not real, while in augmented reality the environment is real and the objects you're dealing with, those are the virtual ones. So if we look at augmented reality, there are two key questions that you have to tackle to decide or to set up such a system. Those are: how do you show those informations? How do you show the virtual information that are now in the real world? And where do you show them? Starting with the left side, those are the different display technologies that you use. So the HoloLens is one example of a head-mounted device. So you put it on, you have the screen directly in front of your eyes, and you can see the whole environment. And there are at some points your virtual information in there. So that is the head-mounted display that you're using. Spatial displays, not that common. Could be that you have a room where projectors are projecting on the scene, and it can do it in a way that it looks like there's something floating in front of you. Sort of like a cave system when you have your glasses on and that you see the information in there. Could also be a screen that is, it looks like you're looking through that screen, sort of like on a bus stop, but on there are then digital information, and it looks like you're seeing through that, but it's actually then a video playing or something. And the one that we'll be talking about today, handheld displays, where you have your normal phone and you can look through it like with the camera app, and then in that feed there are digital information embedded in that. And that has, of course, a couple of differences to the head-mounted device. So one, the screen is not right in front of you. You only have a small area. That area is seen through a camera, so you can also move it around, shift the viewport without moving your head, and stuff like that. But for our purposes, yeah, it's the camera view, and you're embedding digital information in that. The second question, so where to show the information, is relying to tracking the environment and figuring out where is the world, where are the different models in there, and where do I have to render my object so that it looks like it is in that location. And for that, we have to track, yeah, for example, the surfaces in the scene, to track where is the location of my viewing device. In our case, the iPhone, where is it, from what position is it looking at the screen? That's here the second part, so that you directly see the environment. If you want to interact with the world directly, so if there's a virtual bottle rendered here on the table, I need to track my hands or some other input device so I can grab the bottle and interact with the scene. So how does the right part now work when we're using a smartphone? So the first set of sensors that we're using are the gyrometer, accelerometer data, so tracking the device position in itself, detecting the movement, detecting the rotation and stuff like that. So it's not linked to the real world per se. It doesn't know where a table or a surface is, but it knows, okay, I'm looking to that direction, now it's moving to the side. So early augmented reality apps, they showed something right in front of the screen, and when you move to the side, they just noticed that movement and shifted the model accordingly, so that it looked like, yeah, it's floating in space. But if we want to track the environment, what is used for this are the cameras at the front and back of the device. So with the camera, you can the system tracks different features, different edges, for example, that it sees in the environment, and by shifting the movement, how those markers, how those features change, they can determine where in the scene or from what position they're looking at that location. And we'll see an example of that. The front-facing camera, or the front-facing camera array, also has different cameras, different system sensors that they can use. So for unlocking your phone, there's also Face ID that projects a grid onto your face and to track really detailed features. That can also be used to track your face for AR, that you can know, okay, from what position is the user looking at that scene. So while the back-facing camera is usually used to track the environment, the front-facing camera at the moment is mostly used to track the face. And those are these different dimensions. So with the back-facing camera, you have your world tracking, where you detect objects in the scene and the position of the camera looking at that. While with the front-facing camera, you can do face tracking, map the face, and get the movements of your face, so you can display Snapchat filters, stuff like that. So how does this look now when we're using ARKit? ARKit has essentially two main components. First is the AR configuration, that you specify what the system should be looking for, what algorithms are used to detect the environment, what camera is used, and stuff like that. And the AR session is just managing how that is running. So when you leave, for example, the camera view, the scene where you want to display your information, that you pause the session so that the computation also stops, and resume it when you get back to that scene. And when you use the general templates that Xcode offers, there's already AR SceneView, or what's the other one? SKView. I think there are views that you can use with SceneKit or with SpriteKit, depending on what you want to do. And they offer you the commands for that you can directly start. So, like I said, the configurations, looking at what algorithms to use. And there are different configurations. For example, the world tracking that is tracking the surfaces, environments in the scene, and the position. Body tracking, I think one group is looking particularly into that, is tracking a person and the movement of the limbs, so you can use it, for example, for occlusion of virtual information behind it. Orientation is just, where in the space is the camera looking, so it's not tracking the surfaces, but only the position and orientation of that. Image tracking, if you want to detect a marker. So that was, for a long time, the most prominent use of augmented reality on smartphones, that there is a marker or an image that's detected, and on that marker or in relation to that marker, there are information then displayed. And then face tracking, using the front-facing camera and getting the information about the face of the user looking at that. There's also another one that is not that relevant for our use cases, because it doesn't care about the video scene. It's just about tracking the movement, the position of the device. So it's using the environment, but not giving you any information about it, just to track it if you want to use it to navigate in a completely virtual scene, for example. And a second configuration that is a little bit different is object scanning. So you can also use ARKit to scan an object and then display information when that object is seen or detected. And to get the information that the system should be looking for, you need to scan it first. So that is where the object scanning configuration comes in. So it's a configuration you will use more on the internal application. So you have your object and you use that to move around it to get the information that you pass on to your other app that should then detect that object. And the other part, the session manages the camera and the processing of the data, and you run the session with a certain configuration that you set up, and also if you leave the scene, you just tell the session to pause, so that no resources are wasted when you're not showing anything or you're not reliant on the tracking. And what we'll be looking into mostly today is the world tracking configuration. So what is possible with this? What can you do, and how do you interact with that? Or how do you use it? So at first, you have to specify what you want to look for in the scene. What information do you want from the system when the system sees something? And most basic or most often used is plane detection, where you tell the system, okay, notify me if you see a free area that you detect as a plane. And that can be either a horizontal plane, so like on a desk, or a vertical plane, a wall, for example. And you will get information about these properties, how large are they, where in the scene are they. Second is image detection. So you specify an image and you want the system to notify you when ARKit is seeing that image and where it is in the scene. And as I already mentioned, object detection, seeing where in the scene is this object and when has this object been detected. And yeah, last year what also introduced a world map, meaning information about the scene in terms of where are different anchors, where are different feature points that can be used to restart or resume your whole application, your whole setup at the same location after you've closed the app and restarted it again. Or also to share it with other devices. So if you look at the same scene, the objects that you see are actually on the same location and in the same space in your world. And all of these visualizations, all of these the camera feed and what you get, there are displayed in the AR SceneView. And if you use the AR SceneView, it's automatically taking care of aligning the different coordinate systems that you're using. So if you use SceneKit, you have your coordinate system in which you place your objects. Where is the origin and how do these objects stand in relation to the origin? And if you use the AR SceneView, that is automatically aligned with the world origin that ARKit is tracking. So you're working on the same distances, locations, and so on. So if you place an object at a specific location, you already know that is linked to the real world, the real coordinate system that you're using. And it also takes care of the camera. So when you then move your device around, the position from where you're looking is directly matched to the camera property of your SceneKit view. So you can determine, okay, from what position am I looking at this, and how do I interact with that? You can use the SceneKit to directly see basic statistics in terms of frame rate and how many informations are seen, or how many feature points does the system have. And feature points meaning what are the elements that ARKit is using to track the scene, to look at the scene. It's also helpful then for debugging to see those information that you can see, okay, why does it not work in this location? If you display the feature points, then it will become easier to see, okay, there are nothing that the system can track there, so that's probably the reason why something is not as stable as you want it to be. And you have different options. One is also to show the world origin so that you know, okay, it's aligned that way. I already always expected it to be in a different orientation. So that's why your models are floating around or standing at a different location than you expected. And of course, there's also Delegate for this view, that you get notified of information for the most prominent if features that you've defined that the system should look for are detected or updated or removed, that you can look at those. So since we already talked about feature points, this is one example where you can then see all these little dots are used by ARKit to hold on to the scene, and then they are tracked from frame to frame to determine, okay, from what position is ARKit or the camera now looking at the scene. And for the environment, there are a couple of things to look out for, or things to keep in mind, and what effect it does have on the tracking precision. So first, if there's just a plain wall or just a plain surface, it's not possible to really get many feature points, distinct features, and that will degrade the tracking quality. If it's dark, similar thing, it's hard to get the features. But also if there's too much light and there are reflections, that's also problematic, because ARKit doesn't make sense of what it tracks in that regard. So it can't determine whether a bright spot is a circle on the table that it can align to, or if it's just a reflection from a light that you're seeing. So that also makes it problematic. And since it tracks these feature points from frame to frame, if you move the device too quickly and too far, then yeah, of course, it will also not be able to track those features. In that case, the information you get from the device motion, so accelerometer data, gyro data, are then much more prominent. And ARKit already merges these information so that when feature tracking works good, it relies more on that. But if that is problematic, then it also relies more on the device motion, and in between merging them to get a more precise reading. So if we want to track a surface, we first have to tell our configuration, okay, that it should track surfaces and what to look for. And that is by assigning whether you want the horizontal or vertical surfaces tracked to the plane detection property of the configuration. And then you have to implement a couple of delegate methods. So they are all did add node, did update node, or did remove node for a specific anchor that is passed over with it. And the anchor is what ARKit uses to specify this particular surface, for example. And then, yeah, you can check whether the anchor that is passed is a plane anchor, and then depending on the alignment, whether it's horizontal or vertical, react to that, display something, whatever you want. And yeah, we don't need a little detour for the switch case. We don't need a default case because the alignment property can either be horizontal or vertical, so that is already exhaustive. So the anchors that are passed over, they are not only to differentiate between the different types of features or different features in general, but they also hold a bit more information that you can use in your system. So, for example, you have the anchors for a lot of the different features that you want to track. So whether it's a plane, whether it's a face, and so on. So you can use that to differentiate what type of feature you're looking into. But there are also then the information more specific to that anchor. So for example, for the plane anchor, there is about, okay, is it a vertical or a horizontal plane that was detected? Where's the center? How large is it? What geometry does it have in sense? Or for an image anchor, what is the image that was actually then seen, and what are the dimensions of that? So you can use that to then fine-tune your whole experience. So looking at the image anchor, if you want to track a specific image, how do you set that up? And for that, you have to specify first in Xcode what image your app should look for. And for that, in the assets folder, you can create a AR resources group and just drag your image in here. And very importantly, you then have to specify what is the real physical size of this image. So what is the width, what is the height, so that the system can understand if there's an image or it sees an image of this size, but in reality it's 10 meters in height. Okay, it will be very far away, so it can calculate where in the world is now this image, and how large is it? Yes.
You're talking about picture or object in the picture?
No, the picture. So the size of the image that you're passing over as the image that the app should look for. And yeah, if you specify, okay, it's 20 centimeters, if it sees it, now it's, okay, an object of 20 centimeters, and now see it in that size, it will be that far away. We'll see an example. So, yes?
Two questions. What units is it using? Pixels
You can specify. So at the moment it's set to centimeters, but you can pixel. You can.
I thought it would automatically put the properties of the image inside.
Yeah, but the image that you put in might not be related to in what size you've printed it out. Right? An image of a you can have a large panorama of a landscape, so it's quite large, but you print it out just on a small postcard, and you need to specify what is the real-world representation that you want your app to look for, so that it detects what is that. How does that look in the real world? And yeah, you specify that for the reference images that you load the specific group that you put your image into, and add that to the detection images of your configuration, and then it will look for that. And by default, it assumes that the position of this image or this target will not change, so it has a quite low update rate. If you want to track the movement quickly, you can also specify in this property that it should track it more continuously, or how many targets it should even look for. And then when you get past an image anchor, you can use the property to get back to the original size that you used for the image, or that the image should have to react to that, to scale your objects wherever you want. And yeah, like I said, we'll look at that in the demo. Then the last part, if you want to interact with your scene, the objects that you have there, the environment, you have the option, if you tap or touch your screen, that you cast array then into the scene to select the object that you've tapped on, for example. And the way to do that is, first you have to get the position where your screen was touched, and what position of your scene view does it correspond to. And then from that location, so from the touch location that you got, you shoot array into the scene, and specify what features, what interactions you want to look for. So there are a couple of different types, whether it's directly trying to hit a feature point, or whether it's on the fly estimation. Okay, that looks like here is a plane, give me that information, or I only want information about planes that are already tracked, that ARKit has an anchor for, so it returns those information. And from the result that you get, there are, of course, the information about what type of interaction, what type of feature was hit, and which anchor was it, so you can get more information about those, but also about the distance and transforms, meaning how far away from me was the hit target, so the location where my ray intersected with the real world, and what is the transformation that I need to apply to an object to look into that. But yeah, all that will become a little bit clearer in a demo. So let's look at that. I will quickly and I will just create a new Xcode project, and there is already this template that you can use, basic setup for augmented reality. So just call it ARKit demo. We're using Swift, and the technology that we're using to render our information, you have the option between RealityKit, SceneKit, SpriteKit, Metal. For this, we'll look at SceneKit to just quickly show the different properties here, and using storyboards. So let's just place it somewhere. And with the demo that we've, or the template that we're using, there are already a couple of things that are directly set up for us. So for example, you notice here the switch that on. No. Where was that? Better. So you have here your SceneKit assets, and in there's, for example, the ship that we want to display, or is in the template directly used to display an object in your scene. You have in your view controller, that's just probably not that full screen. Do it that way. You have your SceneView here directly connected that you're using. So in the storyboard, you'll see that our main screen or main image is already in AR SceneView that we can use. And this view controller is also our SceneView delegate, so it receives the information about the tracking. And since this is set to self, this view controller is also the delegate for that. The statistics are enabled, so you can get a basic information about the rendering performance and speed. And then we'll just use our ship scene as our starting scene and assign this down here to our scene view. And then when our view appears, then we specify the configuration. So at the moment set to world tracking configuration, so you can shift that to whatever you like, and just run our session with this configuration. And similar, when our view disappears, then we can pause this session, so we're stopping the calculations there. So first, what we want to look at is a couple more debug options that we see the feature points that are tracked and see where's our origin. So for this, look at our scene view and set a couple of debug options. And for this, we have debug options. And there you can see, where do we have that? Yeah, can show the cameras, show skeletons, wireframes, whatever you want. We will just look at the world origin and also the show feature points. And so let's see if we, or when we run this, how that works, or how that looks like. So first, of course, we need to give our app the permission to use the camera. And then we have here our scene. And you can see the feature points that it tracks even there on the floor. And the big thing here, that is our world origin. And in the standard, the world origin is always where the camera, where the application is starting. So I held my phone down here, so that is where the origin is. And then this ship looks like, yeah, it's sitting in that location. And at the bottom of the screen, you can also get the basic statistic information, how many frames per second at the moment, and stuff like that. So that is already then from the directly set up scene or application template. And now we want to look at different planes or search for different planes. So how we do this is for our configuration, we specify that it should detect planes. So for the configuration, we set the plane detection to look for horizontal and vertical planes. And then this is already then set up, and now the ARKit notifies the delegate once it sees such a plane. So within our SceneView delegate, we'll just add the method did add a node for this specific anchor. And so that is called when a anchor has been seen, and we'll just quickly check that it is a plane anchor. So we only want to react to plane anchors at this point. So we'll just try to cast the anchor to an AR plane anchor. And should that not work, we'll return. So if we are here, we know that the anchor was a plane anchor, and we'll just want to display a plane now at on the surface that we have tracked. So this method we'll write later, and at the floor, my F key doesn't work, to that. So at the moment, our create floor method doesn't exist, so we'll quickly write that. And that will return to us a node. It's very similar to SpriteKit, how this works. So I won't go into details on how the node. Oh, not that way. How interacting with SceneKit is working. We have one group to look at that in more detail. So for the node, we'll just create an SCN node. And every node that we want to display needs to have a geometry specifying what is the object that should be displayed. So we create a geometry that is just a plane and has at this point just 1 meter by 1 meter in size, and assign this geometry to our node that we want to display. And we want to return the node so that that error goes away. For planes, there's one specific setup how planes are created for SceneKit, and that is that there are sort of standing up. So if we want a horizontal plane, we just need to rotate it. So we'll just rotate our node 90 degrees so that our plane is flat. Like I said, this is not now going quickly through those points. I want just to have the opacity a little bit lower, that our node is not occluding everything. So with that, let's run. Now, if we move around, you can see there's probably not on our screen. Let's look at our desk here. Let's move up the opacity a little bit more. So that's clearer to see on our projector. So if I look down here, that is what the node or the plane that we are looking into here. That is displayed, and that is fine, but it's definitely not showing us the whole area, and it's not updating for that. And for that, yeah, we need to be aware of changes that ARKit sees in the scene. So this is at the moment, we only get notified when a new anchor has been seen, when something new has been detected. But when you're moving your phone around, ARKit also updates its current information. So we want to get notified when it, for example, detected, okay, this plane is bigger than I expected at the beginning, and want to react to those changes. So for that, we'll just update our create floor first to detect or take a plane anchor as well, so we can use those information. So AR plane anchor, and so that we can use, instead of setting it directly to 1 meter by 1 meter, that we can use the information we get from our plane anchor. So for this, we can use the extent that we get from our plane anchor. Extent meaning what is the size of the plane. So for the first, or for the width, we used the extent in the x dimension, and for the height, remember that moving down, or that we have to rotate it anyways, we have the extent in the z direction. So that is the depth in our SceneKit scene. Everything else stays the same for now, but here we have to pass over the plane anchor so that you can get those information. At this point, it's just okay, the initial size of the plane that that we get. But to react to changes, then we have to react to the update. So for that, we have the did update node for the specific anchor, or for a specific anchor. And here, again, we're just checking that the anchor that we have is a plane anchor. But then also we want to directly unwrap the information that we want to use. So we need the node that is holding our plane that we want to add up. So that is from our node that was passed over. Since we just added that node as a child node, we want to get the first element there. So that is our plane node. And lastly, the geometry that was linked to this node as a that we want to have that as a plane. So that is from the plane node that we just unwrapped the geometry, and since we also directly set that before, we can cast it to be of an SceneKit plane. So what we did, to quickly go to go again over this, first we checked that the anchor that was passed over is an AR plane anchor, so it is that information, and we assign it to this plane anchor property. Then from the node that was passed over, so the node that is attached to linked to that anchor, we take the first child node of this, similar to SpriteKit, SceneKit also using the node hierarchy, and so taking the first element in there and setting that as our plane node. And from that plane node, we take the geometry to be or encast it to a plane and assign this to the plane that we got. So this is essentially this geometry then that we've specified here. And so after this guard statement, we can assume that everything from that exists. So we can update our information. So first, that the position of our plane node, so where in the scene is this location, we can update it to be at the center of our plane anchor that we defined. So we get the plane anchor center position. Should be directly on the surface of the plane, so our y dimension is 0, and then plane anchor z, that is then our position, so that the center of our plane is in the center of the anchor, the plane anchor that we've detected. And then we just update also our plane properties, so that the width of our plane is also the extent of our plane anchor that we detected. So we're just updating the properties that we've specified before. And now with this, our application should update based on the information that it sees in the scene. So in the beginning, we have this size, but if I move it around, you can see that the plane is growing to encompass more information the more it sees within our environment. Any questions so far for this that immediately pop out? Okay, then let's continue with the image tracking. And for this, I have here this image that I want to track. And yeah, if you've been here at the chair, you know that androids are a little bit problematic, also with our professor, so we need to hide those from him. So every time our app sees the android, should just place something on top that it doesn't show the androids. So, like I said, for the assets, we first need to specify, we need to tell Xcode what to look for. So we have here in our assets also the option to create a new AR resource group. And we can drag our images in here. So I have the Android images, or image, looking like that. And we'll just drag it in here. And you can see that there's already a warning attached to this. And this is because I need to specify the size of this image. So in what is the real world size of our image, so that I can that the system then knows, okay, this real world thing, in what distance to the camera is this. So for this, here I have the different units that I can specify, centimeters, inches, feet, yards, whatever. I've measured this here so that it's 25.1 centimeters. And from the aspect ratio, it already then, of course, fills in the height. So this image is 25.1 centimeters in width. So now Xcode knows this. So to tell our application to look for it, we first then need to update our configuration. So for our configuration, we need to first load the images and assign those to the detection images. So first, we load the reference images. That is our reference image. Reference images specify the group they are in. We use the standard setup thing, so AR resources. Bundle is not important. To take a little shortcut, we are just unwrapping this explicitly. Of course, in your app, you would need to check whether that actually exists and is there. And then for our configuration, we add this to the detection images. So now we have told the configuration to look for this Android image. Now for the our did-add delegate method, we need to differentiate whether a plane was detected or whether the image was detected. So instead of using the guard, we'll just switch over the different elements from our anchor. So first is if we have the plane anchor. So we cast the wait, let me quickly we cast the anchor as an AR plane anchor, and if that works, then we'll go into what we've already specified here. So we'll just copy this in here. So that is in the case for if we detect a plane. But if we have an image anchor, then we want to create our plane in that we use to what is that? Oh yeah, I haven't written. To display on top of our image so that we can't see it anymore. So first we get the reference image that is attached to our anchor. So from the image anchor, get the reference image. That is the information that we passed over to Xcode about this image. So the plane that we want to display over it should have the width of our reference image. So reference image, and there we can get the physical size. So that is what we've specified the size of our image there to be. So get the physical size width, and for the height, similar reference image, physical size, height. So with that, we have a plane of the same size as our image. We want to set the color for that. I will just put this in UI. So that will be just setting the color of our plane to red. And then, we take a node that we want to attach this plane to add it to our anchor. So we create a plane node, with this geometry of the plane that we just specified here. And again, similar, we need to just rotate this so that it is flat on top of our image. Okay, so and now we need to add this to the node that we've passed got passed over. So node add child node our plane. And if we get into the default state here, that is something, yeah, since we're not looking for anything else, shouldn't happen. But just printing out that we saw something completely different. So, quick recap. If we see an image anchor, we just take get the information about our image, and then create a plane with the same size, width, and height of this reference image. Set the color of our plane to red, and just rotate it so that it's flat on. So it should be, once the camera sees this image, just display a red plane over it. Let's see if that works. So there we have camera view, and once I get over here, yeah, then it will just block out everything. But you can see if I move it around, it takes some time to update. So yeah, still not acceptable there. And what we need to do to cater for that, we just specify that it should continuously track the images, so continuously update the tracking. So, and in order to do that, we just set the maximum number of tracked images just to 1. And that specifies, yeah, continuously update those, and just look at this image and try to be as precise as possible. And so if we go back now here, so now if we see it blocking out, and if I move the image around, it will be, yeah, if I get too far, too fast, then it's still visible. But in general, now the tracking is way more precise in updating to that. Any questions regarding the image tracking? Yes?
With the speed, how would you fix that?
What do you mean with the speed?
We're moving very fast.
At that point, it is so fast that it doesn't get across, so I'm not sure that you can get faster. I think one reason why it switched was because the cable is in front of it. Let's see if I can. It's difficult to keep it in view without having the cable sitting there. So, I mean, here, if I go faster and it has a clear view, it's almost not noticeable. It's always, if I clip it a little bit so that the whole image is not seen, then of course it goes back. If it's here a little bit bent, then it's more difficult. But if it is flat on the surface and I have it in my view, then it is quite stable for that.
When you're tracking more like people or anything, you want to cover them.
If you want to track people, then you should do the body tracking.
Okay.
So I think we have one group that's looking particular into that. So we'll get more information about this. Okay, so far about just showing information. If we want to interact with our scenes, then we'll need to implement our hit testing. So for that, we'll just add a gesture recognizer to track our tab. We'll just add this to our SceneView. So we have here that information, and let's just go to our editor and link our tab gesture recognizer to code. we want to have passed tap gesture recognizer, and the action when we tap it, just call it scene tapped. So we have here our IB action that will get called once our screen has been tapped. Where did I edit? There. Okay, so now what do we have to do within this method? So first we need to get the touch location of our tap. So for this we just check from our sender where that location is within our SceneView. So with that we have the position on the screen in relation to the SceneView that we're using. And then we just cast array into our scene. So want to get our results, and we do this by, from the SceneView, perform the hit test from the touch location that we just determined, and we want only to get the information about planes that we've already tracked before. So to use that, just existing planes using the extent. So with that, we'll only get notified if if we selected a location where we already know that a plane is. Then, if we have a result, so the result isn't optional, because it could be that you haven't hit anything with our hit test. So we'll unwrap this, get the first intersection that we had with our selection, and for this we just print out Ray hit a plane, and we'll just add a new ship at the location. Again, we'll add this method later. And so with the add ship, we just want to display this ship that we're using all the time at the location where I tapped. So have the hit test result. And for this, first get the ship. And that is, see if I can type it correctly. That is the file that we have here. We're just taking the same one, but since we don't actually want to use the same one, I will just clone it so we have a copy or a clone of the ship that we have been using. Now, to place it at the location, we first need to know where in the scene or what is the distance where our intersection happens. So where is the location relative to the camera? We get the transform property from our result. So there we have the world transform, meaning from our where in our world do I need to place the ship, or where did the intersection of our ray and the plane happen. And we'll just apply this world transform to the transform property of our ship. So now this ship node is at the same location. Since the ship is quite large, we'll just scale it down. 20% of the original size. And then we'll just add this new ship to our scene. So just go through the node tree so we can add it directly into our scene. So let's see if that works. So now, yeah, our scene, our plane has been detected, and if I select it here, we can create an armada of our different planes. If I do it somewhere where no plane has been detected, like here at the moment, then yeah, take some time. If it detects then the plane, it's adding those at the location. So let's add some here and so on. And that is the original one. All right, that short introduction to how to interact with the environment. Any questions about this last thing or anything else we've talked about? Nothing. Silence. All right. Okay, yeah, then I hope you got a good impression to how to start using ARKit and what you can do with that, what are the important setup properties. So that's it then for the last lecture. And 2 groups will have the meeting now. And for everyone else, see you next week.
This content was provided by RWTH, Aachen University.